Hello everyone, I'm Yudhishthira. I welcome you to my YouTube channel WonderChem. So we were discussing the topic classification of elements and periodicity in their function, and we've already discussed about atomic radius in our first video, and if you have not seen that, I'll be sharing the link in the description below, so please watch that. And in today's session, that is S2, I've taken up electronegativity and electron gain enthalpy. So without wasting much of the time, we shall proceed. Now, electronegativity. Now, to define this electronegativity, it is the tendency of an atom to pull the shared pair of electrons towards itself in a molecule. Now, when I use the word shared pair of electrons, the first thing which you have to note is that it is a covalently bonded molecule. So, in a covalently bonded molecule, the electrons are shared between. Now, in this particular molecule, one of the atom is pulling the shared pair of electrons more towards itself. So, this property is called as electronegativity. Now, to make you understand better, I have put up a cartoon over here where you can see a fat man, or you can call him a powerful person, pulling the shared pair of, pulling this rope more towards himself. Now, it is similar with our atoms as well. If an atom is more electronegative, it tends to pull the shared pair of electrons more towards itself. So, then it is measured using Pauling scale. We'll be discussing about this Pauling scale in the next slides. Then, smaller the atom, more near is the nucleus to the adjacent atom. See, I have already told you it is a covalent bond. In a covalent bond, two atoms are sharing electrons, maybe different number of electrons. Now, one thing is, one of the atom which is having a smaller atomic radius will obviously have a closer vicinity to the outermost electron of the adjacent atom. So that makes it pull the shared pair of electrons more towards itself. So that is why I've mentioned this. Now, thus smaller atoms. So when you look at the periodic table, you know that halogens which are present in the 17th group have a smaller atomic radius, which is already discussed in atomic radius session. So I hope you remember that. Now, halogens have smaller atomic radius because atomic radius tends to decrease across the period. Halogens are smaller atoms. So then that means halogen should have more electronegativity. Now, amongst halogens, who is more smaller? We know that it is fluorine. So obviously, fluorine is the most electronegative atom. Then, now I wanted to compare this regular covalent bond where there is no partial positive or negative. You can see charge over here, and HCl molecule. Now, these two are covalently bonded. If you are wondering what is this blurred region, it is nothing but the electron density. Now, amongst two hydrogen atoms, you can see that it is a symmetric molecule and the electron density is clearly shared. Whereas in this HCl molecule, I can see that electron density is varied. I can say that electron density is more towards chlorine atom, less near hydrogen. This is because the electrons are pulled more towards chlorine than hydrogen. So that means chlorine, being more electronegative, is tending to pull the shared pair of electrons more towards itself. Now, it is a covalent bond, and to make you understand this, let me give you a small instance. Let us say two of them are doing some business and have equal shares. So their tendency, the profits, what they share will also be equal. Whereas in this, chlorine has more electronegativity towards itself, more electron density towards itself. Chlorine is more electronegative. So obviously when a person invests more, he will have a bigger or a larger share in the profit as well. So just giving you an example over here. So thus this molecule is polar. Hydrogen has not completely lost that electron. If it would have lost that electron, I could have told this as positive charge itself. But here I mention it to be delta positive, that is small positive charge. And in chlorine, it has got slightly negative charge. Then, now, electronegativity depends on adjacent atom. Now first let us look at water molecule. In water molecule, oxygen is more electronegative. It tends to pull the shared pair of electrons from hydrogen more towards itself and gains a negative charge. And hydrogen atoms will gain slightly positive charge. Whereas the same oxygen which is present in OF2 molecule, here fluorine is more electronegative compared to oxygen. So that is why this electronegativity is always a comparative study. Now oxygen gains a positive charge over here because the shared pair of electrons of oxygen is pulled more towards fluorine atom. Then, so trends in the periodic table, as I was mentioning you about this Pauling electronegativity values, you can see them. Fluorine has the highest value, that is 3.98, chlorine, bromine and iodine. And by this, I hope you can understand, down the group, the electronegativity is decreasing because increase in atomic size. Whereas across the period, if you observe, the electronegativity is increasing because shrinking of the atom, that is decrease in atomic size. So whatever I've told, I would just like to brief you up this. So please note down these 2 points. Next, we shall go ahead with electron gain enthalpy. Now when I say electron gain enthalpy, this is for an atom which can take up a new electron. So the definition goes like this: the amount of energy released or absorbed when an electron is added to the outermost shell of an isolated neutral gaseous atom. Now when I say this, there are 2 special words which I have to see, that is released or absorbed. So talking about energy, I just want to give you one more example, and this concept is a very important one for the knowledge of chemistry. If any species has higher energy, that means it is highly reactive and it tends to be highly unstable. Whereas if a species is less reactive or contains less energy, then that means that species is more stable. So now if the atom gains an electron and becomes stable, then it is going to lose energy because it is attaining stability. Similarly, if an atom gains an electron and tends to become unstable, then that means it is going to be, the energy is going to be absorbed. So let us observe this. It is measured in kilojoules per mole, that is the SI unit for this. And now talking about the main thing. Smaller the atom, more is the inward pull from the nucleus. See, it is just like magnets. You keep the magnets close to iron filings, more will be the attractive force. You keep the magnet far away from the iron filings, lesser is the attractive force. So similarly, smaller the atom, more is the inward pull of electrons towards the nucleus, more will be the interaction with those between the nucleus and the electron, and more amount of energy will be released. Then halogens have high negative electron gain enthalpy. This is an important point which you have to note. See, halogens, as you know, contains 7 electrons in their outermost shell. They are deficient of just 1 electron from attaining octet noble gas configuration. Octet noble gas configuration is a very stable configuration. So if they have to attain that, then when I say they have to attain that, then that means they are moving towards stability. So if they are moving towards stability, then obviously they should be lesser energy species. So when they have to become lesser energy species, obviously they have to lose some amount of energy. So high negative electron gain enthalpy. I hope with the knowledge of thermodynamics you know that if some system loses energy, we tell it as exothermic process and denote it with a negative sign. And if a system gains energy, then we call that to be an endothermic process and it is denoted by a positive sign. So then noble gases have high positive electron gain enthalpy. Now this is again one more interesting thing. See, if noble gases can gain an electron, then they should be taking up that electron to the higher energy level. See, let me take an example of argon. The electronic configuration is 1s2, 2s2, 2p6 or 2,8. Now that means K and L shells are completely filled. Now when you are adding an electron, that means you are adding it to the next energy level. When it enters the next energy level, that means you have to provide more energy because the energy barrier is very, very high. So if you have to provide more energy, that means the energy is absorbed and that is a positive electron gain enthalpy. So continuing. Now this is something which you have to note down, that is chlorine has a higher value of electron gain enthalpy compared to fluorine. You can see over here minus 348 and minus 333. The reason is very simple. Fluorine is a smaller atom. So adding a new electron to this, fluorine on adding an electron becomes negatively charged. So if fluorine becomes negatively charged, that means there is a smaller size and a charge to be possessed. So smaller size and bigger the charge makes the molecule slightly unstable. When I say unstable, that means the amount of energy lost will be slightly lesser compared to chlorine. So that is why fluorine has a lesser electron gain enthalpy compared to that of chlorine. Next, trends in the periodic table. Again, it's the same trend as electronegativity. Electron gain enthalpy increases across the period and it decreases down the group. But I would like to tell you one thing. When fluorine can have a lesser electronegativity, electron gain enthalpy than chlorine, that means there is no regular trend in this electron gain enthalpy. So these are the similarities with electronegativity and electron gain enthalpy. Now we shall look at the differences between them, which is a most important concept. Now for your information, students, please note this video is created for making you understand the concept. So that is why I have not written something which is available directly in the textbook. I just want to make smaller points which make you understand. So please don't write this in your board examinations. Please mention the things properly. Now, electronegativity. Now, it is the tendency to attract bonded electrons. So electronegativity is in a bond, whereas electron gain enthalpy, it is the tendency to attract an external electron which is not belonging to the particular atom. Next, electronegativity is a relative value. We saw the example of H2O and OF2. Remember, electronegativity is a relative value, whereas electron gain enthalpy is exact. When I say fluorine has an electron gain enthalpy of minus 333 kilojoule per mole, that is exact. There is no variation in that. Then regular trend followed in the periodic table. We have seen this with electronegativity, whereas there is no regular trend in the periodic table for electron gain enthalpy. Then for electronegativities, there is no units as such. We just tell it on the Pauling scale. It is a comparative value, whereas electron gain enthalpy can be measured in kilojoule per mole or electron volt. So finally, I would like to thank you all for watching my video. Kindly look up to the next video which I'll be posting, that is S3. I'll be naming that as session 3, which is based on ionization enthalpy, and the link for that will be put on the description below. I hope you all are enjoying watching videos on my channel. Kindly like, share and subscribe my channel. Thank you once again.